Hey everyone, ever since I uploaded my TIC-80 overview video about 9 months ago, I've been getting a lot of requests on making a tutorial series about the fantasy console. So I decided to finally sit down after procrastinating for almost a year and instead of making an entire series, make this one video which covers how to recreate Space Invaders in TIC-80 using the JavaScript language. And since it's a super long video, I'll put all the timestamps down below. You can go check that out and hope you have fun. Alright, so now I'm going to show you how you can download TIC-80 on your computer. So the first thing you want to do is head over to the TIC-80 website, tic80.com. I'll put a link to all of the websites in this video in the description down below, so go check that out. So once you're on the website, you can see a bunch of things like these are games that were made with TIC-80. You can see their social links. But the part that we're interested in is going up here and clicking on the create button. Once you click on create, you can actually use TIC-80 in your browser just to play around for a bit, but you won't be able to save any of your projects. So you actually want to download it for your platform. Since I am on Windows, I will click on the Windows download button and it opened up. So just unzip it, it's just the .zip file. Use WinRAR, 7-zip, or the normal Windows extractor. They'll give you this folder called TIC-80 version whatever. Right now it's version 0.8 for me, but if you're seeing it in the future at some point, it might be 0.9 or 1.2 or something like that. And there'll be a .exe file inside, and you simply open that up, give it a second, and you've got TIC-80 installed on your computer. Now the process might be slightly different on Linux and Mac and Android because it also supports Android. I'm pretty sure for Android you can actually just download it off the Google Play Store, but I'm not sure about the installation on Linux and Mac since I use Windows. Alright, so once you've got TIC-80 open, I'm going to be showing you how you can navigate the program. So the first thing I'm going to do is I'm going to maximize it by clicking on the square icon on the top. And now it'll open up as a console, right? This looks similar to the Windows terminal, for example. If I pull that up, looks pretty similar. So there's many things you could do. As I was saying, you can type in help and this will show you all of the commands. One command that I really recommend doing is the wiki command. This will open up the wiki inside of your browser. I already have it open a few times. Oops, just reopen that. But the wiki looks something like this. Something like this. It'll show you all of the different functions, for example, and this is useful in all of the projects that you make. So I definitely recommend running this command and then just having the wiki open in a separate tab. But like I said, this is the console window, and you can actually make a game here. To make the game, you actually have to head over to the editor window. To do that, you can click on edit, or sorry, you can type down edit and run the command, or you can just click on escape. As you can see, press escape to enter UI mode. Escape is that button on the top left that says ESC on it. And as you can see, it already fills in some boilerplate code, some example code, and you can head over to the different editors. There's a code editor where you obviously type in your code. This can be in Lua, JavaScript, Ren, or Moonscript, I believe. I might be wrong. You guys can double check the wiki to see all of the supported languages. But in this course, we're going to be using not Lua, but JavaScript. So you're going to need some JavaScript knowledge going into this. However, nothing here would be too advanced. If you don't know any JavaScript, I'll put some links down below to some great resources. So this is a sprite editor. This is where you edit all of your sprites. A sprite is just one of the images in your game. So this could be a player, an enemy, a background. all of this is considered to be a sprite. The next is the map editor. Here you can create a level basically using those sprites that you made earlier. This is SFX editor. You can obviously edit sounds here, and this is a music editor. We're not going to be using the last two that much in this course. The one we're going to be using the most is going to be the code one and these two. But we're going to be covering at least these two a little bit as well. We're not going to really be going into the music that much. But like I said, we want to make a game in JavaScript. So to do that, we have to click New. That makes a new cartridge. But if we just do this right now, it is automatically going to be made with Lua or the same boilerplate. So we actually have to do New followed by the name of the language that we want to do. So we want to do JavaScript, so just type in JS. As you can see, this time the code is in JavaScript. And when you run the code, it'll show a little hello world with this little blinking avatar. I guess you can call it an avatar. An icon, whatever. And the code here is pretty simple. You can also move it around, I believe. Yeah. With the arrow keys. And our codes, we're actually going to be using code that's quite similar to this. So before I delete all of this code, I just want to show you this. You see a function called TIC. And what happens is TIC-80 calls this multiple times every second. So this is basically your main game loop. All of your game logic will go through here. Any updating, rendering, all of that goes inside the TIC function. However, I usually like being more organized and creating two sub-functions. One called update and one called render. As you can see here. And then inside of TIC, I call update and render. Make sure you call update first. That's extremely important because you don't want to be rendering stuff before it's all fully updated. That won't end well. I'm also going to click on this button on the top that says F. This just changes the font to this. You can also toggle it back. And I just like this font better since it takes up less space. And it's kind of easier to read. However, if you like this font, you can keep on using it. For the title, we're going to write the name of the game that we want to make. So Space Invaders in my case. I'm going to write the author's name and a short description. And just leave this as it is. This says what language your game is in. So what you want to do now is, I'm going to head over to the sprite editor and use the slider to make the selection bigger. So I'm selecting both of these sprites and then just delete it and bring it back to the normal size. And then I'm going to put it on number 1. So as you can see over here, if I just click on run, nothing happens. So let's make a simple hello world first. If I type in print hello world, and if you ever want to know where I'm getting these functions from, for example, where did I get the TIC function from, where did I get the print function from, it's all inside of the wiki. If I go over here, you can see that there's print, for example. And where's the TIC function? It should be here somewhere as well. Yeah, here's the TIC function. So you can read about all of these functions inside of the wiki. So if I run this code now by clicking this, you can also click Ctrl R to run it, or go back here and click on and type in run. What's going on? It seems like it's not working, right? However, it is. As you can see on the top over here, is showing hello world. However, it's overlapping it on top of everything else. Same thing happens if we run it over here. It just says hello world on the top, but the whole code editor is still here. So we actually want to clear the screen first. So the first line inside of our render function is going to be clearing the screen with this command, CLS. CLS just clears the entire screen. So now when we print hello world, there's nothing left there that basically blocks it. So now that we've got this, we are going to start creating our character. Hey everyone, welcome back. So in this video we're going to start by creating our character. Alright, so first thing we want to do is head over to our sprite editor. and we're just going to be creating a simple spaceship here that'll represent our character, right? Now, I'm not the best at pixel art, so I'm gonna create something that'll look absolute garbage, but if any of you guys are artists, then feel free to create something that looks really good. Alright, yeah, I don't know what I'm doing. I'm not good at art. I'm a programmer. But there you go. This is a spaceship. And this is going to be our player character for the rest of the tutorial. So I'm sorry if you don't like it, but here it is. Now, once we've got this, we want to make sure we get the number of the sprite. Each sprite has a number, so this is number 2, this one will be number 3, this number 0. So our player is number 1. Alright, we have to keep that in mind. Now, inside of the render function, if you want to draw a sprite, the parameters for the sprite function are SPR, that's the name of the function. It's obviously short for sprite. And then over here, oops, my bad. Over here, what you want to do is the first argument is the number of the sprite. So in this case, it's number 1. That's a player. Second and third arguments are the x and y coordinates. So one thing to note about the coordinate system in TIC-80 and basically in all graphic libraries, x increases going right and decreases going left, and like all the way to the left side is x equals 0. So it's just like math class, but unlike math class, y actually increases going down. In math class, y increases going up. This is the origin, this is 0, 0. In most graphic libraries, including TIC-80, 0, 0 is on the top left, not the bottom. So y increases going down and decreases going up. So that's just something to keep in mind. For example, I'm just going to do 100, 100. Alright, now if I run the code, as you can see, renders our spaceship at 100, 100. Let's also get rid of this hello world line, we don't need that anymore. Now I want to centralize this perfectly, and to do that we need to know the screen dimensions, right? And the easiest way to do that is just heading over to the wiki, and as you can see there's a part that's a display over here, right? And it says that the screen resolution is 240 pixels wide and 136 pixels, right? So 240 divided by 2 is 120, so our x is going to be 120. And then 136 divided by 2 is 60... my brain, 68. 68, right? I'm pretty sure it's 68. My brain. And if we run this, it is completely centered. However, now that I think about it, I don't think I want it completely centered. I think I want it closer to the bottom. So let's do like 100 for example. And I think this should be good. We can always modify later if we don't like it. Now that we've got a player, we want to make it move around. To do that, we have to head over to our update function. We don't want to put this in the render function. The render function is going to be specifically for drawing stuff onto the screen. The update function is where we're going to be handling all of the logic, such as key presses, updating positions, stuff like that. So to check if a key is pressed, you want to use a key function. And the function takes in one parameter, which is a key code of the key that you're pressing. Check the key code. Again, just head over to the wiki and go to where is it? I believe it's just under key. You can see the there you go. These are all of the key codes. So for example, let's say we want to use the WASD keys, right? So for up, we want to use W, so that has a key code of 23. So what we're going to do is, if key 23 is pressed, then what we want to do is we want to move up somehow. But to do that, we actually need to store the ship's position. So I'm going to be creating a variable over here called ship. And this is going to be an object. An object in JavaScript is just something that can store different values. It's similar to a dictionary in Python. It's just another data structure. So I'm going to be giving it an X, and inside of JavaScript objects, you define like the actual object with an equal sign, but any properties inside of the object use a column. So X would be, what did we say, 120, and then Y is 100, right? And then instead of drawing the ship at 120, 100, we're going to be drawing it at the ship's X coordinates, right? The X value inside of the ship object, and then ship.y, which is a Y value inside of that ship object. Now if we run it, it'll do the exact same thing because these coordinates are the same as they were before, but if we choose the 220 for example, it's all the way over here, right? So now we want to change the Y coordinate when we click the W key. So to do that, we just do ship.y minus, right? Now when we run it and click W, as you can see, the ship starts going. What minus does is, minus is a short form of ship.y minus equals 1, which is a short form of ship.y is equal to ship.y minus 1. So what it does is it takes the value of the variable, it subtracts 1 from it, and then it sets the value of the variable to that new value. So this will simply make the ship go up by decreasing the y value. Now let's see, else if we click the key for S, which if we go down here, it's 19. So if key 19, and what we want to do is, instead of decreasing the y value, we want to increase it. So now, if I run the game, we can go up with W, we can go down with S. Now to add left and right, this one should be pretty simple. I actually want you guys to try to figure this out by yourself. Pause the video, and I'm going to be showing you guys the answer in 5, 4, 3, 2, 1. Alright, so what you want to do is, it's quite similar to what we did above. We want to use if key, and we want the A key, for example. So A is simply just 1. So if key 1, then we decrease the ship's X coordinates because A will be left. Else if key, we have D, which I believe is just 4. Yeah. If key 4, then we increase the ship's X coordinates, like so. Now we could use WASD to move around perfectly. So we can go in all 4 directions. There's a small problem though. I'm going to hold A and I'm not going to stop holding it, and it disappears from the screen. So we have to find out some way to clamp it to the screen borders to make sure it doesn't get out. Alright? And this is actually pretty simple. So all you want to do is you want to check if the ship.x is greater than the width of the screen. And if you remember, the width of the screen is 240. And then we're going to set ship.x back to 240. But we also want to add one more thing here. We want to add 8 to it, because 8 is the width of the sprite. Remember, coordinates start on the top left. So if we check if it's more than 240, it's going to check if the top left is more than 240, which means that all of this will already be off the screen. So we want to add 8 like this, not bad, 8 like that is greater than 240, and if it is, we're going to be setting ship.x to 240 minus 8. This should be working fine. If we go here, as you can see, I'm holding D, but it's not, I'm spamming D right now, but it's not letting me go past 240, past the screen width. So we're going to do something similar for the ship.x is less than 0, which is the left side. This time we don't need to add 8 because it's already on the left side. We want to check if this is less than 0, and then if it is, then just set ship.x to 0. Right, and now if I hold A, the same thing should happen. I can't get through. Now the same thing for up and down. You guys could try to figure this out yourself. Alright, just pause the video, try to figure it out. Okay, so the way you do this is simply if ship.y if ship.y is less than 0, then you just want to set ship.y to 0. This is the top, because remember y 0 is the top. As you can see, we can go past it. And for the bottom, we actually have to do something similar to this. Follow this one over here. If ship.y plus 8 is greater than, I think it was 136, then we simply want to set ship.y to 136 minus 8. Yeah, so now we've been confined to the screen, and there you go, that is player movement completed. Hey everyone, welcome back. We've just completed player movement. So the next thing we want to be adding is bullets, right? We want to make the player be able to shoot bullets. However, one thing I want to do first is make the game look a bit more aesthetically pleasing, because right now if you just move around and just randomly hit the borders, you don't know where they are, it's kind of hard to differentiate them from the edges of the screen, as you can see over here. So I'm going to be adding a simple background. To do that, you want to head over to the sprite editor, and as you can see, I've already created a simple background over here. I'll just show you how to do it again. I usually like using sprite number 0 for my background. And you just want to create a few simple stars. It doesn't have to be anything complicated. And then once you do that, you just head over to your code, and right after you clear the screen, you want to type in map followed by the number of the sprite that you used. In my case, it was 0. Alright, and once you run it, as you can see, it takes the sprite and it repeats it. However, there is a small problem that's a bit hard to notice with the way this ship sprite is currently, but the background of the ship sprite is actually black and it's not transparent. To show this in more detail, I'm just going to make the background green temporarily. As you can see, the ship has a black background. It's not transparent. So to fix that, what we have to do is we have to get the transparent color. We have to get one color from the sprite that we don't want. We don't want the color black in this case. So as you can see, black is color number 0, purple is number 1, red number 2, etc, etc. So what we're going to do is right after we draw the ship over here, right after ship.y, we're going to put in a 0, and that will not render any black on the ship. As you can see, it's all transparent now, and I'm going to set this back to black because the green just looks horrifying here. There you go, and as you can see, the problem has been fixed. So now we want to add bullets. So the first thing I'm going to do is make a simple bullet sprite. Again, I'm not the best artist, so you know, don't judge me, but just want to make something that looks a little bit like a fireball from space or something. Don't really know what I'm going for. I know. Ooh, is the wrong color. And there. So we've got this simple fireball going over here, and the thing that we're going to do is actually a bit more complicated. We don't want to make an object for it this time. We're not going to do like var bullet equals x this, y this. The reason is we want multiple bullets, right? And we're not going to be creating multiple of these objects. We're not going to be like bullet 1, bullet 2, because number 1, that's going to be a waste of time, and number 2, we're going to run out of bullets eventually. So what we're actually going to do is we're going to be creating a list of bullets. So a list, which is also known as an array, is just a way that you can store values inside as in the form of a list and then loop through them one by one using a for loop. And the other thing we're going to do is create a class. Now, in the version of JavaScript that TIC-80 uses, I don't believe it supports classes. As you can see, it says like parse error when you try to make a class. So what we actually have to do is use functions instead. I believe these are called constructor functions or factory functions. I can't remember the name. But we're going to create a function called bullet. Alright? And then from here, we can treat this as a constructor. We can pass in any values we want to give a bullet. So we want to give it an x value, a y value, and one value which I'm going to call e. I'll explain that in a second. So we're going to set this dot x to be the parameter x, this dot y to be the parameter y, and this dot is enemy bullet set to be the parameter e. So this variable here is enemy bullet is going to be a boolean, which means it's going to be a true or false value. And what this variable is going to do is, first off, it's going to tell the bullet which direction to go. If it's one of the bullets that we're firing, then we want it to go up. If it's one of the bullets that the enemy is firing, or the aliens, or whatever you want to call them, then it'll be going down towards the player. The other thing we want to do is, since we're going to be adding collision detection later, we want to make sure that only enemy bullets damage a player and only player bullets damage the enemy, because when you shoot the bullet, it's going to collide with you. It's going to spawn at your location, so it's going to detect a collision. But we don't want it to hurt you, right, the player who shot it. So that's why this variable is extremely important. The other thing we're going to do is give this a function for rendering and a function for updating. So this is how you make functions in this, or methods, which are functions that belong to a class. And now to render it, what we want to do is simply type in sprite, followed by the number of the sprite, which is 3, followed by the x coordinate, which is this dot x, the x coordinate of the bullet, and this dot y, which is a y of the bullet, and 0 to tell TIC-80 that we don't want to render the bullet, right? And now inside of update, I'm not actually going to be putting anything inside of update for now, but this is where all of the code that checks which direction it's moving in is going to go. So now I want to test whether this is working or not. And to do that, I'm actually going to create a new function called setup. And I want anything that I want all the code to, how do I explain this? Basically anything that I want, any code that I want to run before the game actually starts, that goes inside of this function. So for example, I'm going to do bullets.push. What this does is it adds a new element or a new object inside of this bullets array, and I want to push in a new bullet. So I'm instancing the bullet class, followed by an x coordinate, for example 100, a y coordinate, for example 100, and we're just going to leave it at that for now. We don't need to worry about is enemy bullet. And then inside of rendering, how are we going to render this? Since we want to render all of the bullets inside of this bullet array, how do we do that? The easiest way to do that is a for loop. What we want to do is create a variable for var as I, and this I variable simply is an index variable. So while I is less than the length of the bullets array, right? Let me just write the code and then I'll explain it. So the way for loops work is, we have this variable called I, right? And then before it runs, it'll check if I is less than this value. So bullets.length, which in this case is 1, since we only have 1 bullet. But let's say you shot like 5 bullets, the enemy shot like 5 bullets, it'll be 10. So it'll check if I is less than 10. If this condition is true, it'll run any code inside of it and then increase I by 1. Alright? So then I would be 1, for example. I is still less than 10, so it'll run this again and then increase I. Once I reaches 10, it'll see, is I less than 10? No, it's not. So then it's not going to run this code, it's not going to implement. And it's just going to continue with the code over here. So what we want to do is check the bullets variable. we want to go to I, bullets I, and this is how you access an object inside of an array. You simply type in its index, and since we're looping through the entire array with this variable will represent the index of the element that we're currently on. So bullets I dot render will render all of the bullets inside of the array by looping through every one of them individually and then rendering that one. So now if I run the game, as you could see, where is it? Ooh, there's a bug somewhere. Oh no. Oh yeah, so this is actually sprite number 2, not sprite number 3, my bad. So we're gonna run this, and as you can see, we have a bullet over here now. Sorry, give me a second. So as you can see, we have a bullet next to the player now. Now this bullet actually doesn't do anything, it's just there, but we don't have to worry about it. We're actually just going to completely delete the bullet by deleting this line in the setup function. But now that we know that our bullets are working, now that we know that this code is working, we're going to create a new function called shoot. And what this function will do is, you guessed it, it'll create bullets. So inside of shoot, we want 3 parameters. We want an X, we want a Y, and obviously we want the... Actually, no, I think X and Y should be enough. We don't need the is enemy bullet yet. But actually, we should just put it in there anyways. So what we want to do is simply create a new bullet at XYE, right? And then we want to add this to our array. To do that, as you saw above in the setup function earlier, we just do bullets.push new bullet, right? And then what this will do is whenever this function is called, it'll use these parameters and make a new bullet. So we want to check if the spacebar is pressed. So if key 48, which is the spacebar, remember you can just check the wiki over here. We can go to key, check the wiki, and space is 48. But if you want to use another thing, for example, tab, we want to use tab, then you can use 49. You can use, if you want to use like Z for example, you can use 26, right? So remember that going to the wiki is always an option. So if we close the spacebar, we just want to shoot with the player's x coordinates, so player.x, the player's y coordinates. Oh wait, my bad, it's the variables called ship, not player. So the ship's x coordinates, the ship's y coordinates, and then we're going to write in false because it is not an enemy bullet, it is a player's bullet. We're going to click run. And now when we click space, as you can see, we could just hold space and then it'll spawn a bunch of bullets. It's actually kind of fun. I should make this into a game, like some kind of drawing game. That would be kind of interesting. But the bullets are spawning, right? However, the problem is obviously if you hold it, it just massively spawns bullets. The other problem is that the bullets don't do anything. Let's worry about problem 1 first. This one's much easier to solve. We simply change key to key P. So that way it only detects once. So you have to continuously press the spacebar to shoot. Right? Now we actually want the bullets to move. To do that, first instead of the update function, let's call ship.update. We're going to do something very similar to what we did for the rendering. We're going to create a for loop like this. And then instead of calling bullets i.render, we're going to be calling, you guessed it, bullets i.update. Inside of the bullets update function, which is all the way up here, we want to check if it's an enemy bullet first off. If this dot is enemy bullet, that way we can determine which direction it goes. If it's not an enemy bullet, then it'll go in another direction. So if it's an enemy bullet, we want to increase the y coordinate. Otherwise, we want to decrease the y coordinate. Now when we run the game and hold space, as you can see, the bullets are now going up, which is perfect. That's what we want. And we can just keep on spamming them. However, we're not actually despawning any of the bullets, so after a while it's gonna get pretty laggy since the bullets are all the way up there and they're still updating, they're still going up, right? Their y coordinate is still increasing. So to fix this, what we can do is, inside of this update function, we can simply check if the x of the bullet is less than 0, or these two things over here mean or this dot x is greater than 240, and this is pretty much all you need. You don't need to, oh sorry, I meant the y coordinate, my bad. You don't need to check the x coordinates because it's only going to go off the top and the bottom of the screen. The bullets don't go sideways, they only go up and down. So if one of these is the case, what we're going to do is simply do bullets dot pop this, and what the pop function does is it simply removes an element from the array, and in this case we're going to be removing this. Actually, I think we need to use an index for this. What we're actually going to do is we're going to head down to the update function over here, and after bullets I dot update, we're just going to put this here and do like that, and I think this should work. Oh no, it doesn't work. What's the problem? Why undefined? So as you can see, it says it's on line 6, so that's very useful. If you ever get an error, you always want to know which line it's on. So in my case, it's on line 6, which is over here. That's weird. Line 6 seems fine to me. Ooh, over here, update line 70. Alright, my bad. I'm gonna head down to line 70, which is over here. Oh yeah, we don't want to check this dot y. We obviously want to check bullets I dot y. So the current bullets y coordinate, and it's still a problem somewhere. Oh here. There you go. And now, when it goes off the screen, you can actually see it getting removed. So it is despawning. That's good. Just gonna clear that. Kind of annoying. And there we go. We've managed to successfully add shooting and despawning the bullets. Hey everybody, welcome back to the next video. In this one, we're going to be adding in the aliens, which are going to be obviously the enemies in this game. Now, I actually did make a slight change from the last episode. Before, the code was bullets.pop1. This code doesn't actually work well because it just removes all of the bullets in the array. As you can see over here, if we shoot multiple and one goes off, it will delete all of them. So the code that we actually want to use is bullets.splice I1. What this does is it goes to the I position and then removes one element from it. So that way it'll only remove the bullet that goes off the screen. So I thought I'd just throw that in here. And I'm sorry about that. But now for adding the aliens. We're going to be doing something very similar to what we did here.
I knew you were screaming.
What are you doing? I'm recording a video. So we want to create another class. This class will be the enemy class, so I'm just going to copy the bullet code because the code is actually going to be quite simple. And we're going to simply paste it here. We have to change the name to enemy. Give it an X, a Y. We don't need an E. We don't have to check if it's an enemy bullet because it is an enemy and it's not a bullet. Now to make another sprite for this. To make another sprite, we simply, well, After some more bad pixel art skills. Oh, this looks horrible, but no, I'm just gonna keep it because oh no, this is horrible. This is a disaster. I tried to keep the retro feel going, but I'm not good at pixel art, so this is painful. You know what? This is gonna be the enemy. If you're good at pixel art, again, just feel free to actually make a good alien. So this one is number 3. We have to keep that in mind. In the render function, we're going to be using 3. And I'm going to be clearing the update function as well. We don't need that code. Just like with the bullets, we also want another array for the enemies because we're going to have multiple of them. Now to render it, just copy and paste this code from earlier. You can change the variable names around, change bullets.length to enemies.length, and change bullets i.render to enemies i.render. The code should still be working, nothing's broken, which is good. Remember, if you do get an error, just check what line it's on, make sure you don't have any typos, check to make sure you're using the correct sprite numbers and everything. These are all mistakes that I made in this video so far. And once you've got this, time to actually create a few enemies, which we are going to be covering in the next video. Hey everybody, welcome back. So in the last video we covered creating the enemy class with the render function. So in this video I'm going to be covering spawning the enemies. So if any of you have ever played Space Invaders before, you know that the enemies spawn at the top of the screen next to each other. So a bunch of them are spawning in a row basically. And the easiest way to do this would be utilizing a for loop and then spawning the enemies in. So I'm actually going to create a function somewhere. I'm going to do it right under the shoot function called spawn enemies. Like so. And then inside of the setup function I'm going to call spawn enemies. So now when the game runs, I think I'm calling setup down here. Yeah, I am. So when the game runs, then it will spawn enemies and it'll just run any code inside of this function. So there's no errors yet, which is good. So to spawn the enemies, let's create a for loop. For var I is 0. Oops. Now we need a number. We want it to keep on looping until it reaches a specific number. So to do that, I'm going to get the length of the window, which is 240. And I'm going to subtract 8 because that is the width of the enemies. Right? I don't want any going off the screen, so I'm going to subtract their width from 240. And then I'm going to divide it by 8. So something like this. And oops, should have done while I is less than this number. Then simply add 1 to I, and we are going to be creating a new enemy. So enemies.push. Again, this adds an element into this array, and then I'm just going to type in new enemy. Oops. Inside of the brackets, type a new enemy and give it an X and a Y. So for the X, I'm going to do I multiplied by 8. Alright, so that means on the first loop it's going to be 0. So it's going to spawn at X0. Right, but then after that I is going to be 1. So then it's going to spawn at X is equal to 8. and then the next one is going to spawn at x16, so on, so on. I might actually even change this to be 10, just so there's a small gap in between the enemies. So once we've got this, let's run the code, and there is an error on line 56, which is this one over here. For var I is 0, I is less than this number, add to I. Alright, seems fine to me. What if I do this? Internal error. Let's see. Does it say what column the error is on? I don't think it does. Look at that. Alright, I think it was getting messed up because I was using the brackets. And as you can see, when we run the game, there's these enemies that spawn at the top of the screen. Alright, the enemies don't really do anything, we can just go right through them right now, but the spawning is working. Alright, so what we want to do is we want to run this command every, let's say, 5 or 10 seconds. We can obviously tweak this number. So what I'm going to do is create a new variable over here maybe. I'm going to call this spawn rate. And then I'm going to set this to be 5 for now. And this number will represent the seconds before enemies spawn. Alright, so just keep that in mind. Enemies spawn. And I might actually just turn off the shadows. You can click this button to turn off the shadows. Makes it a little bit easier to read. So what we want to do is create another variable called time. Set this to 0. Oh, actually, I think that TIC-80 might actually have a built-in timer. Let me see, time. Yeah, so the time is the ticks elapsed since the game started. So what we can do is we can take these ticks and then convert them to seconds, for example, which would look like this. You divide the time by 1000, that will give you how many seconds have elapsed. So over here we can do something like let's go to update, all the way down here, and do var secs, which is obviously short for seconds. Var secs would be so var seconds would be time, which, as you can see here, is a function. It's not a variable, so we can't just write time over 1000. That won't work. We have to add the 2 brackets over here. And this will give us how many seconds have elapsed since we started running the game. So here, time will say how many seconds have started from this point. So what we want to do is we want to check if the seconds divided by 5 wait, am I doing this right? If seconds Alright, so to find the time, what we have to do is check if the seconds passed modulo 5. This is a modulo operator. So what this will do is it will give us the remainder of seconds divided by 5. If this number is equal to 0, that means that seconds is a multiple of 5, which means that 5 seconds have passed and we get spawn the enemies here. So we're just gonna run spawn enemies, and otherwise we can actually just leave this blank because we don't need to do anything if 5 seconds have not passed yet. However, right now the enemies are just gonna stay there. Nothing's gonna happen. Actually, to test this out, what we can do is we can go to the setup and we can temporarily comment out the spawn enemies line. So after 5 seconds, the enemy should spawn in. 5, 4, 3, 2, 1. Interesting. So to debug this, let's print what seconds modulo 5 is. But not printed. I don't think it's print. Oh yeah, we have to print this in render. My bad. Let's print this right here. Seconds time over 1000. Module 5. So it's not a number. Oh, because I forgot to have the bracket too. Not bad. So 1, 2, 3, 4. 3.
You streaming?
I'm making a video gun. Why do you keep doing this?
What?
What's wrong with you?
You should close your door.
Hey, close the door and don't come in. You did this yesterday as well? Yes, it was yesterday. Okay, so if we look up here, we could see that, sorry about that, we could see that it seems to be resetting whenever it hits 5. Not exactly sure why. I'm not sure why it's resetting every 5 seconds. It should not be doing that. What if I just print time? Or no, sorry. I'm gonna print this. This is what I want to print. So this should keep going up. It should not stop at that. Yeah, there. So it's going up, which is good. However, if we do modulo 5, it's never at 0. Which means we just need to round it. I think there's a round function built into TIC-80. Yeah, it's just math.round. Or 0. Okay, now everything should be fine. If I delete the print line, we simply need to round this. So math.round. And it spawns in the enemies. Alright. So math.round time over 1000. And then I think we might need to round this number as well. Well, it's kind of hard to see whether they're spawning or not until we start updating their position. So let's start by doing that. Over here, what we're going to do is head over to their update function and increase their X coordinate. So they will go off the screen. Alright, we're not actually calling the update function. So here, just like we did for the bullets, we want to write very similar code. Could also copy paste it and modify it a little bit if you want. But we're just going to run a for loop, checking through the enemies array, and then update enemies.i. not bullets, it should be enemies. And then just run the update function. Okay, so they're moving. They seem to have volume pumped together, and they are spawning. I don't know what's the deal with them all spawning so close together. That seems like what's going on. They should only be spawning once every 5 seconds. Maybe it's because we're using different numbers there. Doesn't seem like it. Alright. And they're not immediately updating either. This is really strange. But let's just continue writing this. Maybe it'll work after we do this. So we want to check if, I don't know why I keep writing bullets. It's supposed to be enemies. So if the enemy's I, which is current enemy's looping on, if the x coordinate is less than 0, or enemy's I.x is greater than 240 minus 8. And I mean, you could just write 232 here, but it doesn't really matter. We want to do actually, I think it's going to be better if we do a separate for loop here, or a separate if statement, my bad. If enemy's I.x is less than 0, then what we want to do is set enemy's I.x set to 0, and enemy's .y plus plus, so this will simply increase their y position. Otherwise, if this condition is met, then what we want to do is again decrease, or rather increase their y position, so that makes them go down 1 row, and then set enemy's I dot x to 240 minus 8. And this should actually be plus equals 8, because that is their that's their length, or height, I mean. Now this won't actually work because they'll still stay in this corner. They don't seem to be moving down though. This is really strange. They're all stuck in this corner, because the reason they're not actually going to the other side is because we have to actually implement a variable called direction, which will tell them whether they should go left or if they should go right. Alright, so I was looking at this code, and what I realized was we're calling this inside of the update function. And if you remember what I said in, I believe, the second part of the video, then you would know that this is called 60 times a second. So it's actually spawning 60 enemies here. When I do this, it's spawning 16 enemies. So that's the reason why this is happening. So to fix that, we're not going to be using the time function that comes with what do you call it? With TIC-80. We're going to create our own variable called elapsed time, for example. That might be a bit too long, so I'm just going to call it etime, which is going to be short for elapsed time. And I'm going to, inside of update, simply increase it by 1. At the start of update over here, I'm going to take elapsed time and add 1 to it, right? And then over here, what I want to do is create a variable called seconds, and set seconds to elapsed time divided by 60, right? So I guess we could even round this, so math.round elapsed time over 60. So what this will do is every second it should give us a value. And I'm actually going to make this a global variable because right now it's just a local variable. So I'm going to add var_sex 0 up here, and that should all be working. I can add a print statement, print seconds, just to test it out. 1, 2. Okay, as you can see, it's all working fine. So what we're going to do is over here inside of update, simply check if the seconds modulo 5 is equal to 0. What we want to do is seconds, or sorry, no. If it's equal to 0, then simply spawn the enemies, right? Is it still spawning 60 of them? Enemies.push new like so. No, it's only spawning 1 this time. Oh, but this one doesn't have a position. It's not spawning 1. Alright, it seems to still be spawning 60 enemies. Give me some more time, I'll figure this out. Alright, so I think I finally found a solution which works pretty well. What we do is over here, instead of rounding the elapsed time, all I did was kept it as a decimal and checked if it was equal to 0.5, and then spawned 1 single enemy in. And as you can see, it's only spawning in 1 enemy. So over here, instead of spawning 1 enemy, if we run the spawn enemies command, everything should be working fine now. As you can see, all the enemies are spawning as they should, which is perfect. So now that we've got this, we just need to, we can get rid of this print statement that I added over here just for debugging purposes. I'll quickly delete that, and let's see. And now what we can do is work on the update function a bit more. So if I head over to the enemies update function, I'm gonna head over to the enemies for loop actually, if I can find it over here. And I'm actually just gonna get rid of this code here and add it right here inside of the enemy.update function right here, and simply replace the enemies I with this. So enemies I.x will become this.x. Ooh, that's the reason it wasn't working. I was writing enemies.y instead of enemies I.y. But I'm just gonna put it in here. That'll make it a bit nicer. And I is undefined. Where did I write I over here? So the code should look something like this. This dot update is function, and we're just checking if x is less than 0, which means the enemy will be on the side of the screen. If it is, then we're going to set the x to 0 and move it down 1 level. Right, so the reason this is happening, this weird thing of them flying down the screen, is because they're still going in this direction, they're getting moved down. Then they're going in this direction again, and they're getting moved down again. Right, so to fix that, what we want to do is create another variable, this.dir, that means direction, and I'm going to start off by setting it to 1, right? And instead of this.x++, we're going to do this.x plus equals 1 multiplied by direction. Or we could just do direction. It's probably a better way of doing it. We don't need to add the useless 1 times. And what we're going to do is, if it's going in this direction, right? If it's less than 0, that means it went in this direction. So in that case, we want to set this.dir, should be this.dir, this.dir to 1, and in this case, you want to set it to -1. Direction 1 means it'll go towards the right, which is my right, which is this way, and dir -1 means it'll go towards the left, my left. So if we run this, as you can see, they reach the edge, then they go down, and then the new ones spawn in, and everything is working well. So in the next one, we're going to be working on adding collision detection in between the bullets and the enemies using the AABB algorithm. Hey everyone, welcome back. So in this video we're going to be setting up collision detection in between the bullets and the enemies using the AABB collision detection algorithm. So I should maybe make a video, like a separate video on the AABB algorithm. It's a really useful algorithm to learn, especially if you're not using a game engine that has a built-in physics library, like if you're using TIC-80, or even if you're just making a game in, for example, pure JavaScript, pure Python, something like that. You just have a graphics library and you're doing the rest on your own. Learning the AABB algorithm is an excellent way, and probably the easiest way, it's at least the easiest way that I know, to implement collision detection without using an external library. So to do that, we're going to create a function or method inside of the enemy class called this dot is colliding with. And we're going to give it one parameter, which is going to be OBJ, which is short for object. So we're going to check if it's colliding with a certain object. And actually, sorry, this should go inside of the bullet class, not the enemy class. My bad. So right here, I'm going to add the is colliding with object method. So what we want to do is check, or rather we can actually just write return, and then we could put the what do you call it? We can just write return and put the So to implement the AABB algorithm, what we're going to do is head over to the bullet class and create a method called this.isCollidingWith. We're going to give the colliding with function one parameter, which is going to be the object that we want to check if it's colliding with. So then we're going to do return, and we want to put the condition inside of these brackets. If this condition is met, then it will return true. If it's not met, it'll return false. So the condition we want to put in here is known as the AABB algorithm. We want to check if the object's x, or if this, which is a bullet, dot x, plus the width of this, which is 8, is greater than the object dot x, right? And these two and signs, these are the this is a symbol you get when you hold shift 7. Looks like this on the keyboard, right? If this dot x plus 8 is greater than object dot x, and this dot y plus 8, this is going to be the height, is greater than object dot y, and object dot x plus 8 is greater than this dot x, and object dot y plus 8 is greater than this dot y. So if all four of these conditions are met, that means the bullet and whichever object we pass into this method, they're overlapping. So what we can do is, inside of the update function, we are looping through. Oh yeah, one other thing is over here, we can simply write, we create a variable for this. Over here, spawn rate, so we can simply replace 5 with spawn rate. But what we can do is we can go down here, and while we're looping through the bullets, right here, this is where we're looping through the bullets and updating them, we're going to create another for loop here. And what this for loop is going to do is, for var j is 0 while j is less than enemies.length, increase j. So as you can see, we're actually looping through the enemies array inside of this loop that's looping through the bullets array. What we're gonna do is check if bullets I, right, this is bullets with the index variable I, the one that we're looping through here, is colliding with the enemy we're looping through here. So bullets I dot is colliding with enemies j. Then we can write some code here. So what we're basically doing here is we're looping through all of the bullets, right? And then we're checking if...
Why don't they say that right? Or like right, even though no one can...
Wanna come in? You can sit down here. So, what we're doing is we're looping through all of the bullets. And then for each bullet, we're looping through each of the enemies and seeing, is this bullet colliding with any one of the enemies? Then if it is, we're going to be running the code here. So what code do we write? All we can do is enemies. Oh, that's not how I write enemies. Enemies dot splice. Give it the index value of I. I'm sorry, j, because we're using j to loop through the enemies. So j and 1, and this will remove the enemy which collides with the bullets from the array. So there seems to be an error on line 23. Let's check that out. I think that's in the is colliding with function. 23 is here. Oh, is it because I put this in separate lines? Maybe TIC-80 doesn't support that. I know it's supported in like normal JavaScript. Oh wait, did I make an error somewhere?
You still in Minecraft?
This is not Minecraft. This is TIC-80. It's a fantasy console. So does that work? That does not work. Line 23. Where's this line? What is the error here? Oh, is it because I'm using the brackets? Might be because I'm using the... Alright, here. This should work fine. No, it does not work fine. There. What? This is so weird. Saying there's an error here. Ooh, of course. My bad. This should be equals function. I was writing it as if it was a method in a JavaScript class, but TIC-80 doesn't support JavaScript classes. We're using functions instead. And now there's an error on line 24, which is this one.
How many errors are there?
Coding is full of errors. There you go, it's finally working. So now if we shoot a bullet, as you can see, oh, okay, that's great.
As you can see, great.
Well,
That didn't work.
Well, it was working, as you could see. If we shoot it, it kills the enemy, but when it despawns, because we have code that makes it despawn, then it seems to be giving us a kind of error because it's undefined. Saying cannot read property is colliding with of undefined, which is on, is it giving a line number? I don't think it is. Clear, run.
Oh, that game looks good. Is that like Space Invaders or something?
It is Space Invaders. I'm creating Space Invaders. 115. Let's check that out. See where the error is. 115 is here. If bullets I that is colliding with enemies J. So when bullets I despawns, oh right. So the error is here, we actually want to despawn it after it's done all of its checks. After it's done all of the collision detection, only then are we going to despawn it. We don't want to despawn it before it finishes detecting the collisions, or else the errors are going to come. And as you can see, we have collision detection working when a fireball or a bullet or whatever you want to call it, when it hits one of the enemies, then they disappear. So in the next video, we are going to be covering the enemies also shooting bullets, which are going to be hurting the player. And then we're going to be adding some score.
Ooh, make a boss!
There's not going to be a boss in this, but you know, if this video gets a lot of likes, let's say 25 likes, then maybe I'll make a sequel where we can add in a boss. But for now, we're going to be adding in the enemy shooting, then we're going to add in some score and game over, and then we're going to be saving the game and exporting it. So see you then. Hey everybody, welcome back. So now that we've successfully implemented collision detection using the AABB algorithm, we are going to make the enemies shoot bullets as well, because at the moment the player is the only one who can shoot bullets, and there is no way to actually lose the game. So I also want to add, or rather give the enemies the ability to shoot bullets. So what I'm going to do is, I actually want to create a slightly different sprite for the enemy bullets, just so they don't get mixed up with the player's bullets. So maybe I can make these ones blue, for example. Like this. Again, pixel art, or art, any kind of art for that matter, is not my strong suit. So bear with me. There. So this is going to be the enemy's sprites. So I'm just going to go back to the code editor, and for the bullets I'm going to add another where is it? Inside of render. Where is the render function? Oh, it's up here. Inside of this render function, I want to add an if statement to check whether it's an enemy bullet or not. So if it is an enemy bullet, then I'm going to upload that in afterwards. But if it's not an enemy bullet, then it will spawn the sprite with the normal texture, which is number 2. As you can see over here, this is number 2. Our alien fireball texture is number 4. So what we want to do is over here, SPR 4, and we can keep the rest of the parameters the same as this one over here. So oh, this should be if this dot is enemy bullet, my bad. So everything is working fine. That's great. So since this is working, we actually have to give the enemies the ability to shoot bullets now. So the way we're going to do this is we're going to be using the seconds variable that we created earlier. This is a variable we used to actually spawn the enemies inside of the scene. So what we can do is check that every, let's say, we spawn them every 5 seconds, so maybe every like 3 seconds. We can make a random enemy shoot the bullets. So inside of here, we can do is we can just keep on looping through the enemies. For var I is 0, I is less than Alright, so we loop through the enemies, and then if the seconds modulo 3 is equal to 0.5, so pretty much the same thing I'm doing here. What I'm going to do is simply enemies I dot shoot. And there's currently no shoot function inside of the enemy class, but let's run it. If it works, it should give us an error. Alright. Inside of the enemy class, we now need to add the shoot function. To do that, we'll create this dot shoot is equal to function. And then here we can do, just for testing purposes, print enemy shot. Right? If I look at the top, so there doesn't seem to be any error, but oh right, it obviously won't print because the screen is clearing it. So what we can simply do is bullets.add. Let's actually write the code to test it out. Bullets.add this .x and this .y. This enemy bullet will be set to true. And let's see what happens. Undefined, not callable. Entry add object.array. Oh, my bad, I wrote add, it should be .push. Line 149. Alright, let's go down. 149. Where's 149? It's over here. This line seems to be fine to me. Line 56, 161, it's 161. Is that just here? Render, so 56. Let's find 56. Ooh, this might be because we are actually defining bullets after we define the class. So maybe it will be better if we grab all of these variable definitions right here, go up, and do this. Nope. Huh. I think there's an error at line 56. Line 56 seems to be fine to me unless... Huh. It's taking an X coordinate, a Y coordinate, and a... Oh, of course. I forgot to write new bullet. My bad. I just put in the arguments. I didn't actually put in the class. I just put in the parameters. Alright, so it's spawning the bullets now, but the enemies are basically turning into bullets. It seems to be killing the enemies. The reason for that is because we didn't tell the bullets not to kill the enemies, so we want the enemy bullets not to damage the enemies, and to do that we can add a check inside of the is colliding with function over here. So right here inside of update, we are checking if the bullet is colliding with the enemies, right? But we also want to add one more little check, and we'll do that using the AND operator. This should be outside of this bracket right here. If the bullet I is colliding with the enemies, and the second condition would be bullets I dot is enemy bullet, and then we're gonna add an exclamation mark here. The exclamation mark means not, so we're checking that the bullet is not an enemy bullet. And as you can see, now when they shoot, it doesn't damage them, but when we shoot, then our bullets damage them, which is good. A problem that we have is that they're all shooting at once, which isn't exactly what we want. That just makes it a bit difficult. So another thing that we might want to do is fix the little error of, you know, they all shoot their bullets at the same time, which isn't something we exactly want. So let's go to the enemy shooting code right over here. So over here we're so one way that we can make the enemies only shoot, basically not all shoot together, is simply updating the update function of the enemies. So what we could actually do is just go down here and we can delete this line here. We don't need that big block of code. Then we just go up and we go to the enemy class, which is over here, and then go to the update function. And inside of this update function, I'm going to add another line of code where I'm going to say math.random100. What this does is it generates a random value in between 0 and 100. Or actually no, I'm thinking of a different language, sorry. I'm really tired right now. But you just do if math.random, and what math.random does is it gives you a number in between 0 and 1. Alright, so what we could do is check if it is less than or equal to 0.1, for example. And if it is, then we can run this dot shoot. Right, so there is currently about a 10% chance of the enemy shooting. And as you can see, that's definitely way too much. So let's stop that, maybe 0.01. Now there's a 1% chance of the enemy shooting. That seems to be so much better already. So as you can see, we can shoot the enemies, and they all die when we shoot them. Their bullets currently don't affect us. Now, we want to make the enemies have the ability for their bullets to damage the player and end the game. So to do that, it's actually quite simple. All we have to do is head over to the update function, where we see this collision check. What this is doing is it's checking if any of the bullets are colliding with the enemies. So we're actually going to do something quite similar. We're just going to go here and check if bullets I is colliding with, and then we're going to type in the ship, because we want to check if it's colliding with the ship. And we also want to add one more condition. We want to check if bullets I is enemy bullets, because obviously we don't want our own bullets damaging the player. And then if both of these conditions are met, simply type in reset. Reset is another function that you can find inside of the wiki over here. Go down, and I think I'm already on reset actually, and it resets and immediately resets the cartridge, which is basically the game. So if we get hit by one of the enemy bullets, as you can see, everything gets reset, but if we get hit by our own bullet, nothing happens. As you can see, there you go. Now let's try to add some kind of storage system, or sorry, scoring system, not storage. So to add a scoring system, what we're gonna do is go to where we're defining all of our variables, create another one called score, and set this one to 0. Then what we're gonna do is go to here, the update function, and right here where one of the enemies, if the bullet hits one of the enemies, then they get removed from the game. Simply do score plus plus. This will increase the score if any of the enemies get removed. Now inside of the render function, we're just going to add a simple print score. And what this will do is, you guessed it, print the score on the top right. Wow, I'm so bad at my own game. But as you can see, I got 7 points. You shoot a few more enemies. Oh. Yeah, I'm not, as you can see, I'm clearly not a pro at Space Invaders or anything like that. But the game is working. We might also want to add some sound effects for when the, for example, if it's game over, we might want to add a sound effect. When we shoot a bullet, we might want to add a sound effect, right? So to do that, we can go to this SFX editor. This is one we haven't touched yet. And for example, over here, we can simply edit some sounds. So we can choose all of these different things here. And I'm not actually the best with the sound editor, but for example, you could create sounds like this. Over here, you could create different kinds of sounds. And then you can hold space and then play them. Yeah, this isn't the most appealing sound, but you know, you can change it like this. You can modify all of these things to create some pretty weird sounding stuff. You can change which notes it uses, for example. So we just want a simple shooting sound effect. So what we could do is this sounds good. And I don't even know how I did it. Let me try to actually remake that sound. So, you know, you could just play around for a bit. And eventually you'll get something that sounds good. So like, this could be a nice shoot sound, for example. So each one of the sounds, just like the sprites, they all have an index, right? So this is index 0. And if we want to play that whenever we shoot, we can go to the shoot function, if I can find it. So, sometimes it's kind of hard to find which functions you're looking for in TIC-80, but I guess that's why this exists. Let's find the shoot function. There you go. And then to play a sound effect, you just write SFX followed by the sounds index. Why is it still playing that? Oh no. Let's stop that. I think I might be doing something wrong, so just like before, we can just head to the wiki. It seems like the SFX command has changed a little bit since the last time I've used it. Ooh, it has a duration thing. Duration is the number of frames, which is -1. For default. Yeah, so this actually wasn't a thing before. It wasn't -1 by default before, back when I made the overview video. I haven't used TIC-80 much since, which is probably one of the reasons I'm making so many of these dumb mistakes. But let's try 30 frames. No, let's not do that. Is this my I'm modifying the note by mistake. Alright. So the note by default . I wonder what the note by default is. Let's try, I don't know, 3. Is that good? Oh no. 3. Alright, 3's our note. I just used, like this is number 3, I guess. Or a name. Oh, we can use a name. So this one is E1. So can we just do E1? Does that work? Okay, that works. So our node is E1, and then our sorry, and then our duration can be set to 30. Okay, there you go. We now get this awful sound effect when we shoot. And then maybe we want a sound effect when we lose the game as well. So if one of these bullets hits us, we might want a sound effect for that. So to do that, we can go here, go to index 1, and then create a new sound effect. For example, we could use this one. So index 1. Again, let's see which note this is. This is note C1. So right here where we're checking to reset, we can do another sound effect. Index 1, note C1, duration. This one could be a bit longer maybe. So if we get hit by one of these, it doesn't work. That's great. The note is C1. C1. So it has to be uppercase? Is that right? No, maybe it has to be inside a base string. That would make a bit more sense. Yeah, okay, it has to be a string. But as you can see, when the player loses, it plays that sound effect, and when the player shoots a bullet, it makes this sound effect. And then we'll also set the other one to a string. It seems like we're using some kind of variable there by mistake. That can lead to all sorts of strange errors, so let's not do that. And now we've basically got the entire game working fine. Another thing we might want to do is change the text color. So if we want to change the text color, all we have to do is we can go down to where we're printing it. And then if we want to change the text color, we also have to provide an X and Y value. 1010, that seems a bit too much. Maybe we can keep it at 00. That's pretty good. And then the text color. So to do that, we go here. This is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if we want white, we can go to 12. You can pick whichever color you want. I think white works pretty well for this game. It's pretty easy to see on the black background. And that is our game finished. In the next video, we're going to be exporting the game and saving it. See you. So now that we've finished our game, the final step is obviously to save the game and to export it. So to save the project, all you have to do is type in save followed by a name of a file. So we can call this test space invaders, and it says cart test space invaders .tic saved. .tic is a file format that TIC-80 saves all of its files in. Now you can type in dir, that will list all of your files. I've actually already saved this as tut for a tutorial, obviously, so I have a copy of it over here. But if you want to load a different one, for example, I've created this Fallen Skies kind of game. You can just type in load followed by the name of whichever project you want to load. Not Space Invaders, Fallen Skies. And now if I run it, it's a different game, right? This is, I think this was the first game I made with TIC-80. Can't remember, but it's a funny little game. And obviously we can go back, we can load test Space Invaders, like so, and we can run it, and as you can see, it is our Space Invaders game. If you want to actually see where the file is on your computer, you can type in folder, and this has, give it a second, this opens up a file explorer. Oh, my bad. I didn't mean to close everything. And as you can see, this has all of your .tic files. This over here is our test space invader .tic. You can even open it in Notepad if you want, but you could just send this to your friends if they have TIC-80, and if they have TIC-80, they simply put it inside of this folder and they can run it. But what if they don't have TIC-80? Well, thankfully, with TIC-80, you can actually export your games quite easily. You just load it in. I think I already have it loaded. I do. And then you just type in export. And then you can type in HTML or native, I believe. So if we export HTML, it's going to do some loading. And it's going to open this up. It's going to ask us where we want to put it. I'll just temporarily put it on my desktop. And it'll save it as a .zip file. You could also export native. And what this will do is, if you're on Windows like me, this will export it as a .exe file, and if you're on Linux or Mac or whatever, then it'll export it as your native file type. So if I go here now to my desktop, I have, let me just grab these, not this, what an inconvenient space to put it. Over here, I have test space in .zip and the .exe. If I run the .exe, for example, give it a second. As you can see, it opens up TIC-80 Tiny Computer, and here's our game all working. We can full screen it if we want, but this is our, we can click escape, and we can resume, reset, we can configure some stuff here, and we can close the game as well. And there you go. So we have it as a standalone .exe. You can send this to your friends. You can put this on itch.io. Sorry. You can send this to your friends. You can put this on itch.io. It's just a standalone .exe file. Now for the HTML file, you actually need to run it in a web server, and I could set that up and show you, but it'll take some time. So you could just take my word for it that oops, sorry, I don't know what I did there. But just take my word for it that this will work. You can upload it to itch.io and people will be able to play it there, or whatever you use. You can send it to your friends. You can upload it to a website, whatever you want. And there you go. There's a complete recreation of Space Invaders using JavaScript in TIC-80, all saved and exported to a .exe file and or a .html file. So thanks for watching, everybody, and I'd love some feedback, because this is the first video of this type that I've ever made. So we'll love any feedback in the comments. Thanks for watching, everyone, and see you later.